gradually the rate of activity decreases. The velocity of engine increases with the increased temperature, but after reaching the optimal temperature, then gradually the velocity decreases. Is it clear to you? Velocity of enzyme activity increases increasing temperature up to maximum. Maximum is when it declines. The velocity of enzyme action, enzyme activity increases with increase in temperature up to a maximum, that is optimal temperature, and then it declines. Clear? So a bell-shaped curve is obtained, and bell-shaped curve is obtained. The velocity of enzyme action increases with increase in temperature up to a maximum. Then it declines and a bell-shaped curve is obtained. Clear?
Yes, sir.
So this is what are the factors controlling temperature. Next comes to the role of pH. Almost same curve you will get here. Is it clear? Again, every enzyme has a particular pH to act. Increase in hydrogen ion concentration gradually increases the enzyme activity. After then it declines. Again, a bell-shaped curve is obtained. Gujarat. Look, is it clear? Increase in hydrogen ion concentration considerably influences the velocity of enzyme activity and a bell-shaped curve is obtained normally.
Ito. Set up na natakbo.
Each enzyme has an optimum pH at which each enzyme has an optimum pH at which the velocity of enzyme activity is maximum. Each enzyme has an optimum pH at which the velocity of enzyme activity is maximum. The opposite chain. Is it clear up to this pH and temperature?
স্যার উপরে জায়গাটা কি লেখা আছে একটু বুঝিয়ে দাও।
Each enzyme has an optimum pH at which the velocity of enzyme activity is maximum. For example, I am telling you for trypsin, optimum pH is 8.5. So, if it is 8.5, what is the curve of trypsin? Here you will get the maximum velocity of the enzyme. Are you getting me? Beyond 8.5 or below 8.5, there should not be the maximum velocity. Are you getting me?
Yes, sir.
So this is what is written here. Each enzyme has an optimum pH at which the velocity of activity, enzyme activity is maximum. So this is optimum pH. After that it declines. After that it declines. Is it clear? Both the cases, for temperature and pH, the bell-shaped curve is obtained. Next one, concentration of substrate. Maximum velocity of enzyme action at infinite substrate concentration, that is called Vmax. So these are value of Vmax and Km. What is Vmax and Km? maximum velocity of enzyme action at infinite substrate concentration is called the Vmax. That means once all the active site of the enzymes are occupied by substrate, then there should not be any increase in the enzyme velocity. So again, after that, if you add more and more substrate, then also there will be no increase in the rate of enzyme velocity. So this why it is called maximum velocity of enzyme action at infinite substrate concentration. Now, Km refers to the concentration of substrate at which the velocity is half of its maximum velocity. This is a half Vmax. This is whenever the concentration of substrate required to fill or occupy 50% of the active sites of the enzymes. Then you can get it the half Vmax. If there are 6 enzymes like this, I am telling you. You see, all active sites are occupied by the substrate, then you will get the Vmax. You know, all active sites are not occupied, only 50% of the active sites are occupied. Then you can call it half Vmax. So Vmax is obtained when all the active sites of the enzymes are occupied, and half Vmax is obtained when 50% of the active sites are occupied. So this is what about the meaning of half Vmax and Vmax. This is clear, I think. Now,
স্যার
বলো
স্যার ভিম্যাক্স এর মধ্যে ইনফাইনাইট সাবস্ট্রেট কনসেন্ট্রেশন মানে
look one thing. If suppose whenever all active sites are occupied by the substrate, we get this curve. Okay. If we even then add more substrate in the medium, there will be no increase in the enzyme velocity. That's why it is called Vmax. Are you getting me now?
ইয়েস স্যার
Now Km value is a good indicator actually. High Km value indicates quick affinity between enzyme and substrate. High Km value is more. It indicates weak affinity between enzyme and substrate. When it is low Km, indicates strong affinity between enzyme and substrate. Sometimes you see in the medium, if 4 active sites are occupied, if whenever 4 active sites are occupied, then we get half Vmax. If for occupying 4 active sites, 4 substrates are only to be given, then we are getting the maximum affinity. But if you add four enzyme, four substrate, but they are not going to occupy the active sites immediately, so that you need to add some more substrate, so that 50% of the active sites are occupied, then you can call a low affinity or weak affinity. Is it clear?
सर একটু বলো না আরেকবার
Suppose here what is it? Four substrates are given and we get half Vmax. But in the other case, suppose look here, four substrates are given, but two are found to occupy the active sites. Again, you add some more substrate. Then only % of the active sites are found to be occupied. So what it is found here, only four substrates are required to get half the max, but here to facilitate occupation of four substrate, suppose 4 to 7, 8 substrates are to be given. So more substrates given, then only four substrates occupy the active site. So here substrate concentration increases. That is CAM increases. So here it is a weak affinity between enzyme and substrate. Is it clear now?
yes sir clear
So this is the concentration of substrate. So now from here we have to give you one equation. To মুছতে হবে। বুঝতে পারবি না he means
এখানে কি লিখছো
enzyme দেখা যাচ্ছে না E plus S means substrate, E means enzyme, K1 by K2. Actually they are the constant. Then enzyme substrate complex is called, then in the presence of K3 they become enzyme and product. দেখা out. Velocity constant. So from here we can get the Km. What should we write in the Km? Equal to K2 plus K3 by K1. From here, V means velocity of enzyme action. The value of the V is if V equal to half V max, provided if half Vmax. Km plus S equal to now বুঝতে পারছি concentration of substrate. Now, in this circuit, the Km refers to the concentration of substrate at which velocity of enzyme action is half of its maximum velocity. So, একটু কর just 2 minutes, just 2 minutes.
ईपी
বুঝলাম না?
ওই যে ই প্লাস পি যে লেখা আছে পি মানে কি
P product.
Oh.
Product. Okay, now coming to the cofactors. মুছে দিটা
স্যার ভি কিভাবে হাফ ভি ম্যাক্স হয়েছে?
হ্যাঁ
স্যার ভিটা কিভাবে হাফ ভি ম্যাক্স হয়েছে?
না ভিটা হাফ ডিগ্রি সাজে হয় 50% is equal when 50% of the suppose velocity is such that velocity of enzyme action is such that 50% of the active sites are occupied by the substrate. Then the velocity is half of the maximum velocity, right?
ও ঠিক আছে।
মুছে দি হ্যাঁ কোনটা K1 actually they are the velocity constant. Km is the substrate concentration at which generally we get the half maximum velocity. If you just compare these two, K2 and K3, E plus S K2 when ES2 become ENS and then you will get the K3. So these are the constants which help in the breakdown of enzyme substrate to the enzyme and substrate. And also it is the enzyme substrate to product. That's why these two are to be added. And here, how many enzyme substrate complexes are to be formed, and if you divide by this constant, then you will get the Km. These are the velocity constant. So that ultimately we can determine the V. V means V max X into Km plus S. বুঝতে পেরেছি এবার?
স্যার
হ্যাঁ বলো।
স্যার প্রথম ইকুয়েশনটার মধ্যে যে ই আর এস লেখা এটা কি এনজাইম আর সাবস্ট্রেট?
হ্যাঁ enzyme substrate.
এটা কি ইনটু মাল্টিপ্লিকেশন একটার সঙ্গে?
Multiplication of the enzyme and substrate when binds, then enzyme substrate complex is formed.
আচ্ছা বুঝেছি।
Then comes to the cofactors. Segregate between coenzyme So cofactors are the non-protein parts of the whole enzyme. Is it clear to this? Binds loosely to an apoenzyme, binds firmly to an apoenzyme and accelerates enzymatic activity. Example, zinc is the metal activator. Carbonic anhydrase enzyme. So this is all about the coenzyme, prosthetic group, and metal activator. Is it clear to you?
স্যার
হ্যাঁ বলো।
স্যার প্রস্থেটিক গ্রুপের নিচে এটা কি লিখেছো?
Binds firmly to an apoenzyme.
এক্সাম্পলটা
The heme, HAEM. Heme is the prosthetic group of catalase enzyme. Clear? Now is your task now. You have to find out the metal activator of at least 10 enzymes. You have to find out the metal activator of at least 10 enzymes. Can you?
Yes, sir.
Okay, you do it. This is your home task. Metal just find out the metal activators of 10 more enzymes. For example, for pyruvate kinase, it is potassium ion. Okay. So clear about the coenzyme, prosthetic group. Then we are proceeding towards the inhibition of enzyme action. The Mushri. হয়েছে সবার? Inhibition of enzyme action. Competitive inhibition. competition between substrate in this case, there is a competition between substrate and substrate analog. Substrate analog is a compound which is similar in structure to the substrate for occupying the active side of the enzyme. For occupying the active side of the enzyme. Then look, in this case, there is a competition between substrate and substrate analog for occupying the active site of the enzyme. When question of substrate analog is more than the substrate, then substrate analog occupies the active site of the enzyme and enzyme activity is inhibited. In this case, there is a competition between substrate and substrate analog for occupying the active site of the enzyme. When position of substrate analog is more than the substrate, then substrate analog occupies the active site of the enzyme and enzyme activity is inhibited. Clear?
Sir, analog mane?
Analog is a structure which is, for example, succinic acid is the substrate of enzyme succinate dehydrogenase. Substrate analog of succinic acid. Clear?
না স্যার মানে অ্যানালগ মানেটা কি?
Analog means a structure which is very similar to the other structure but not the same. Then the term used is analog. Substrate analog means malonic acid is almost similar in structure. I am showing you one thing. Just a minute. CH2COOH and CH2COOH. They are the succinic acid. But regarding malonic acid, same structure, almost same. This is the structure. So here is the difference. In structural difference, is it clear now? This is the malonic acid. That's why it is the substituent analog of succinic acid. Structurally, you will get here. Is it clear now?
Yes, sir, clear.
Now coming to the comparative inhibition. Competitive inhibition. The reaction, I am writing reaction first. And this is the product. Clear? Now, malonic acid binds to active site. Binds to active site of succinate dehydrogenase enzyme. Inhibition of enzyme action. So whenever the concentration of malonic acid is more than succinic acid, obviously malonic acid will occupy the active site of the enzyme, causing inhibition of enzyme action. Now, where another condition, when concentration of succinic acid is more than malonic acid, then what happens? So, this is what happened when concentration of substrate is more than the substrate analog, then substrate is found to occupy the active site and enzyme action resumes or starts. So that we get the product and alternative product becomes free. That means in case of competitive inhibition of enzyme action, if enzyme activity is to be continued, then more substrates are required to be added. Some more substrates are required to be added in order to prevent the malonic acid or the substrate analog from occupying the active site of the enzyme. If no substrate analog is present in the medium, then the number of substrates required to be added to get half Bmax. And if substrate analog is present in the medium, then obviously more substrates are required to be added than the previous time to get half Bmax. Is it clear to you?
Yes, sir.
Is it clear?
Yes, sir.
Okay. Now I'm going to show with the help of a curve here. এটা মুছে দেবে একটু।
স্যার একটু
মানে অ্যাকচুয়ালি সপ্তমী অষ্টমী নবমী curve obtained when there is a competition between substrate and substrate analog for occupying the active site.
So উপরের জায়গাটা দেখা যায় না,
হ্যাঁ
তো উপরের জায়গাটা দেখা যায় না, উপরে
বুঝতে পারছি না
তার উপরের জায়গাটা
to remain same. So here in this case, you need to remember this. Vmax remains same, but can increases. In this case, Vmax remains same, but can increases. Vmax remains same, but can increases. Clear?
স্যার প্রথম কি লাগছে এটা কার্ভ
Curve obtained when there is a competition between substrate and substrate analog for occupying the active set. This is in case of competitive inhibition.
আচ্ছা স্যার 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 যদি সাকসেনিক অ্যাসিড আর মেলানিক অ্যাসিড যদি ইকুয়াল কোয়ান্টিটিতে থাকে
Then anyone can occupy.
Oh, আচ্ছা।
It cannot be predicted actually. That means in case of competitive inhibition, if enzyme action is to continue, in case of when there is a case of competitive inhibition and enzyme action is to continue, then you need to add more substrate. And that's why Km value increases. These substrates are for preventing the substrate analogs from occupying the active site of the enzyme. That's why we say in case of competitive inhibition of enzyme action, Vmax remains same because there is no change in the efficiency of the enzyme. Enzyme will be efficient similarly, but as substrate analogs are present in the medium, some more substrates are to be added to get half Vmax. Clear?
Yes, sir.
Okay. So আজকে অবধি থাক, I am to close now, and then the next class will be on next Thursday. Okay, for a class to next Thursday medium. When there is no substrate analog in the medium, when there is no substrate analog in the medium, then you can call it normal curve. 4 active sites are to be occupied, so 4 substrates are sufficient to get the half Vmax. Then this is called normal curve. Where you will see that the substrate is there is no competition between the substrate and analog because there is no analog there. But there is a site found in the enzyme where an inhibitor can bind to decrease the efficiency of the enzyme. This is called non-competitive inhibition. Again, you will get some irreversible inhibition. Some toxic substances like hydroacetate, whenever binds to the enzyme activity is inhibited irreversibly. You will get it. After that, in this chapter, you will go through the what I said regarding the allosterism. Some enzymes have some allostetic sites. Whenever any compound binds to this allostetic site, conformational change of the active site occurs, so that either the enzyme becomes functional or non-functional. So only these things are, so 2 things. One is non-competitive inhibition. Second one is irreversible inhibition. Third one is allosterism, which includes positive allosterism and negative allosterism. I am repeating you again, I am telling you again and again, don't forget to go through every single line of NCERT book, please. This year almost all questions are coming from NCERT book. Please go through every line. Sometimes line is directly taken from the book. I am repeatedly telling you, to have a very good result, don't forget to do this. কারো কথা শুনবে না, sometimes misguiding. Please go to this book first. If you go to this year questions, you will get almost all questions are coming from the NCERT book. But the thing is, you need to go through every single line of this book. Every single diagram you need to understand. This is the basic thing. If you have any problem even understanding a particular line, don't hesitate to tell me. Then obviously I will make you understand. Possibly I actually used to go through every line of this book, but sometimes it is not possible. Sometimes I am going beyond it to visualize you. But you need to remember this thing. What I discussed beyond the NCERT, it is for visualizing the whole fact about this chapter. Are you getting me?
Yes, sir.
Don't forget this. So that's all for today. Happy Puja, enjoy Puja, obviously maintaining all these things.